Woo! Now that's some serious thrust.
This is an MHD drive, or a magneto-hydrodynamic thruster.
Bit of a mouthful, but also a remarkably exotic way to create underwater thrust.
Look, propellers and engines are great at producing thrust, but they're also great at producing noise. And marine animals, they don't like that. MHD thrusters, on the other hand, they have the potential to be totally silent because they don't have any moving parts. In fact, the only thing that moves is the water. Instead, they capitalize on a rivalry between magnetism and electricity in order to create thrust.
Woo! They've been popularized by Hollywood and then put into actual practice by the Yamada 1 boat over in Japan. So I set out to build the most compact, powerful thruster I possibly could.
This video is sponsored by Keysight Technologies, who are giving away over $100K worth of lab equipment during their Live from the Lab event.
I'd heard of magneto-hydrodynamic thrust before. It sounded super sci-fi and interesting, but never really gave it much thought.
Until I put out my last video about an ionic thrust catamaran. You guys bombed the comments section requesting I dig into this, so I geared up for an underwater thruster. Funny thing is, MHD thrust and ionic thrust are essentially cousins. While ionic thrust works best accelerating gases, and it does an amazing job, MHD thrust works best with water, but they both rely on electrified mediums in order to create thrust.
You may have heard of MHD drives before if you've watched The Hunt for Red October. In an attempt to be stealthy and hide from a US submarine, they activate their Caterpillar drive, which has no moving parts and is totally silent. It's an MHD drive.
In their simplest form, they use 2 electrodes and a magnet. When the electrodes are placed in salt water with one attached to positive and the other to negative, and a sufficient voltage is applied between them, the water undergoes electrolysis. But that's about it. However, when a properly oriented magnet is placed between the electrodes, that all changes. This time, when sufficient voltage is applied, something incredible happens. The water begins to move in one dedicated direction, and that flow of water can be very noticeable. And why this happens is beautifully simple. With the water electrified, a horizontal electric field is present between the electrodes. On the other hand, the magnet's magnetic field is oriented vertically. When a magnetic field interacts with an electric field that is oriented perpendicularly, the electric charge carriers experience a force in the z direction. That is called a Lorentz force. And in this case, what are the charge carriers? The electrified water. This is also how a railgun works.
Ion wind propulsion, or more generally electrohydrodynamic propulsion, which can also be called EHD propulsion, works by accelerating ionized air or another electrically conductive fluid, utilizing only electric fields instead of magnetic fields. Speaking generally, EHD, ion wind propulsion, has a lower thrust given the same volume compared to MHD propulsion. In technical jargon, this is called power density. While there is a distinct difference between EHD propulsion and MHD propulsion, in many cases the two can overlap and may even be used together in the same vehicle. This explanation can be even more easily understood if one were to stop and consider the meaning of the term ion wind. Ion wind, or as it is sometimes called electric wind, is produced when an intense electric field causes a breakdown of air, forming a cloud of like-charged ions or electrons depending on the polarity of the field. The ions' electrons are repelled by the electric field and each other, expanding outwards or moving towards an electric field of opposite polarity. In the process, the ions or electrons collide with neutral air molecules, creating a wind away from the initial electric field, either outward or toward another electric field of the opposite polarity.